Okay, number one is kind of a hard question, but it's really just trying to get you to think about how these shapes compare to one another. Okay, so I'm just going to start with that. I want it just says, which square, the large, medium, or small, covers more of the plane? Explain your reasoning. Who has an answer? Chase, which one do you think covers the most space?
White.
Okay, why do you think that?
Because it's bigger than those two green ones combined.
Okay, so Chase said he thinks white takes up the most space because the white one is larger than two green ones. What would he need to add to finish that thought? Jude?
And the yellow ones.
Okay, and the yellow ones. But what if there were, the number of green and white would be important here? Naomi?
Because the white one is the same size as the green one and two small yellow ones.
We almost have to compare color to color because we're trying to figure out which one takes up the most. So let's go with Chase's thought, okay? I'm just trying to get us to complete that thought. Chase, say one more time what you said. The white takes up more space because one white is bigger than two green. So how many white are there? 5. Okay, if there were 15 green, would Chase's thought still be true? So let's add numbers to Chase's. So Chase says, I'm going to write this and then we'll discuss if we agree or disagree with it. You don't have to write this yet. Chase thinks that the white, which is the large, takes up the most space because 2 green is less than 1 white, right? Smaller than, I'm just going to use math symbols. 2 green is less than 1 white. So, if there are 5 white, because that's the number, right? How many green are up there? 10. So if there are 5 white, then it would take more than 10 green I'm just going to put to be larger. What do I mean by to be larger? To take them. Oh, I can just write that. It's about the same amount of words. It'll take more than 10 green to take up more space. Does that logic make sense? Does that logic make sense? That reasoning makes sense. What about the yellows? What would we have to figure out with the yellows? Nolan? We have to compare the yellows to something just to make sure. Nate?
To see it, take the yellows and see how many it takes to fill up the white.
Yeah, see how many yellows it takes to fill up the white. Just by looking, what do you think our guess is going to be? Jude?
4?
I think it'll take more than 4, won't it?
Yeah.
I think it'll take maybe 9.
Yeah.
See how right there? Okay, so if I draw that in, you can, and I stayed with the lines of the yellow boxes. I used that one and that one to help me draw that in. So it takes 9 yellow to make 1 white. There are 5 white, so how many yellow would I need if yellow took up more space? 46, because of more than 45. Now let's use these pictures here. If I draw this right here, I'm drawing that line. Can I get the side somewhere? That one's not at the bottom. Could I fit 2 of those in that piece right there? Nope, so I'm just going to put 1 in there. Oh, why? It's this piece right here, from there to there. So there's 1 green. Even if I use this piece and that piece to make a second green, is this piece still left over? Yeah, so I'm still proving Chase's theory, okay? He is saying that two green boxes, so this green right here and that one that we had to split right there, are are smaller than one white. Is that true? Yes, and I just proved it. So do we agree with Chase's thought process now? Yes. What would have made this problem easier? I mean, because here we almost had to look and draw lines to compare. What would have made this easier, Sadie? If it was on grid paper, we could have just counted. That would have made it a lot easier. Something I'm going to give you for lesson 2 is this stuff, okay? It's like parchment paper, or some people call it tracing paper. It's all very similar. It's actually for cooking, the stuff I buy, because it's cheaper than tracing paper. But I can buy it in these nice little squares. How could this help me with this problem if I don't have grid paper? Could I use this parchment paper, trace over that, and then trace it over there and see if it's the same size or double or triple? So we're going to start, you guys are all going to get patty paper maybe tomorrow. I can't remember what lesson we actually need it in. It's 2 or 3. Jack?
You also couldn't use the green to tile because it overlaps. It would overlap.
So yeah, so he's saying if I tried to tile with the green in the white, it would overlap. So we'd almost have to chop it in half to get it to fit. You're right. Okay, so that is technically the correct answer. And that logic makes sense. So if you had something other than the white one, I want you to go ahead and write this in. Okay, or if you had bits and pieces of this and you can just add a little bit to it to make it better, go ahead and do that now. Okay, so you're making your decision by comparing one of the shapes to the other. How many of the yellow does it take to fill the green? How many green does it take to fill the white? By doing this, did anybody do it this way? What am I doing? I'm filling the whole paper with yellow squares. Did anybody use that logic? No one in here said it, so. If I did that, what can I now do? Jack?
Count the squares.
Now I can count squares. Now I have the grids. So your reasoning, if you chose to do it that way, you would say I broke it all into yellow squares and I just counted. The green took up 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 4 is there. So there were 40 yellow squares in the green squares. In the yellow squares, how many yellow squares did we have? 10 yellow squares. And then I could count the white squares. 1, 2, 3, 4, 5 times 9 is 45. Does that logic make sense also? Okay, that's one thing about this book, and this first lesson's the hardest because it's a brand new book and there's lots of right answers and there's not just one way to get to an answer. That's why if someone came down to help yesterday, what did I tell you? Anybody come down for help? What did I tell you?
Do it by yourself.
I want you to attempt it. Do whatever you think needs done. Because I don't want you to tell you the way I would do it, because does my brain work just like yours? No, but hopefully if you spent time on this and thought about it, one of these ways I showed you makes sense to you. Does that make sense? Okay, and again, that one was a weird one. I'm not denying that. Number 2. Before I draw any of these, it said draw 3 different quadrilaterals, each with an area of 12 square units. Jalen, what is a quadrilateral? Okay, a 4-sided figure. So all of your figures in number 2 should have 4 sides. Sophia, what could the dimensions be of a four-sided figure if the area is 12? What could the side lengths be?
You can try and do like 4 on the side and then 3 on the top.
Yeah, a 4 by 3. I'm just going to write the dimensions out to the side and then we'll draw them in a second. So 4 by 3. When you're doing these, always try and do completely different ones if possible. So what do I mean by that? If I say I want you to try and do completely different ones, what do I not want you to tell me next? Sadie?
That, like, keep doing like 4 times 3, 4 times 3.
Well, instead of 4 times 3, 3 times 4, because that's technically the same one. If it asked for like 5 of them on this one, we would have to use some of those reverse ones, which would just turn the rectangle to its side. But if possible, try and give complete different ones. Stella?
12 by 1.
12 by 1. Any others? Livy? 2 by 6. Are there any others? Okay, so there are 3 complete different ones. How many total could I do for this one then, Jack? 6, because I could flip all of those. So now 4 by 3, I'm going to go down 4 over 3. You could have done that one, or you could have done 3 down, 4 across. Okay? Those are technically the same rectangle, just turned. But those two work. 12 by 1. Are there even 12 going down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is one, there is only one direction I could draw that one. Okay, 2 by 6, 6 by 2. Let's do the 2, 1, 2, 3, 4, 5, 6. That way, or we could have gone 1, 2, 3. Okay. So there are the 5 that you could have fit on this grid. Mark, how many of those did you have to do?
3.
Just 3 of them. Now, I didn't tell you this yesterday because this is the first one that we have done. Anytime you have to draw shapes on grid lines that aren't numbered, write out the dimensions on the side. So like this one, just show like, hey, that's 4, that's 3. This is 3, that's 4. 2 by 6, 1 by 12, 2 by 6. Because occasionally, I'm sure none of you would do this, but when you're doing this, like on a quiz or a test, you get in a rush, and when you're trying to count to 6, you actually count to 5. But if you draw 5 and write 6, I do give you partial credit, and I write slow down. Raise your hand if you can think of someone that may make mistakes like that sometimes. Okay, so that's why it is extra stuff to do, but it's really to prevent you from losing points for easy stuff later on. Okay? Questions on that one? Next question, number 3, had the most questions yesterday. If it's asking you to tile the plane, okay? If you are asked to tile a wall, if it's asking you to tile the plane, you want to be hired, not fired. So in part A, what should my picture look like? What criteria should it meet, Reese?
It should be like the same way the one rectangle is.
Okay, so a repeating pattern with no gaps or overlaps. That's all you had to do on this one, is repeat that pattern with no gaps and overlaps. So I'm going to continue in this row first. It's 3 across, 3 across, 3 across. Now, you could do those same things up and down. You could have even have staggered it a little bit if you wanted to. What does it mean to stagger it a little bit? Like not start them in the same spot. Okay, because on your walls in your kitchen, like your tiling, if you look at them, they're usually not one tile directly on top of each other. It's almost like one row shifted. Okay, and where people struggle is at the end. Like if I start the first one here, Okay, I can't leave that open. On your wall, do they just leave a piece that's not covered, or what do they do, Jalen? Yeah, they cut the tile. So just show like that there's a piece of a tile there. And the only reason it's different is because it's at the edge. It's not that your pattern's not the same. It's just that but if I went over one that way, maybe we'll just repeat that pattern. So we'll go here. Okay, now on the, see how I'm doing every other row the same? So now this one I would go here. Now I have to match that top row, so this piece has to be cut to fit my pattern. I just tiled the plane. Okay, so to help you remember from what we talked about yesterday, if it asks you to tile the plane, I want you to write hired. Okay, if you tile like that, you're going to be hired. So what do you think we want on not tile the plane? Jude?
Fired.
What?
Fired.
Yeah, we have to get fired. We have to do a job that is going to get us fired. So we want to look like a kindergartner tiling a wall. They're going to put the mud on the back, or mortar, whatever it's called, and then what are they going to do? They're going to stick it wherever it'll stick. So let's stick a tile right here. Okay, then they're going to be a globby glue and put a whole bunch of stuff on the back, and what are they going to do with another tile? Stick it in a random spot. Okay, draw a few more tiles on there. And then make sure it's a job that you would get fired on and you have successfully not tiled the plane. Sadie.
So I did it like tile, but then I left like a gap.
That's fine. Leaving gaps. Just try not to leave the gaps around the outside edge. Because, why?
You could just put it back, cut a piece.
Yeah, in real tile jobs, they just cut the pieces around the edge. So sometimes there are, and they're not gaps because they fill the gaps. It's just with pieces rather than full tiles. So if you leave gaps, try and leave them more in the center, and we didn't discuss that yesterday. Does that problem seem a lot easier than it seemed last night?
Yes.
Okay. Next one. And this one we're not just going to circle, we're going to add to some of these. The area can be found, the question says, the area of this shape is 24 square units. Which of these statements is true about the area? Select all that apply. The area can be found by counting the number of squares that touch the edge of the shape. Dane, what do you think? Is that true or is that not true?
True.
The area can be found by counting the number of squares that touch the edge of the shape?
Oh, no.
Okay, why is that not true?
Because it's all the squares in
It's
the shape.
all of them. So here's what I want us to do on that one. We're not going to circle it because it's not true. But I want you to box this in right here. That little piece of the sentence is what makes this incorrect. Okay? It's not the ones that touch the edge of the shape. What do we call that if it's touching the edge of the shape, Naomi? Perimeter. That would give us the perimeter, not the area. So we're going to box that in because that's what makes this one incorrect. Part B says it takes 24 grid squares to cover the shape without gaps and overlaps. Is that true about the area? Nolan?
Yes.
Yes. So we are going to circle that one. How could we verify that one, Max? How could we decide that that one was true?
You count all the squares.
Yeah, you go over there and you count 24 grid squares and see if that's how many it took to cover it. C says the area can be found by multiplying the side lengths that are 6 units and 4 units. Jalen?
That's true because 24 or 6 times 4 equals 24.
I agree with part of what you said. 6 times 4 is 24. Sadie, but tell her why she's incorrect on this problem.
Because it's 6 down here and then it'll be 6 up here, but it says 4.
Yeah, so Jalen, let's pretend I didn't give you the answer already. Okay, and that's why they did that. They said 24 right here because they knew you'd get here and say, oh, 6 times 4 is 24. Jalen, if I gave you this picture and I said, Jalen, find the area, would you say, oh, I take 6 times 4? No, that's why this one's false. Again, they made those numbers work out very nicely to make your brain think yes. Jalen, what would I need to do to that picture to find the area?
You have to multiply 2 times 6, or either like cut it.
Yeah, you'd have to chop it into 2 because we don't have a formula for a top hat to find the area of a top hat, okay? So she's right. We would have to chop it into 2. Keep going with that train of thought. What would we have to do?
6 times 2 is 12, and then you would do 4 times 3, which is 12, and then you would add 12 plus 12 is 20.
Okay, so she is correct there. So is C correct, Jalen? No. D says the area can be found by counting the grid squares inside of the shape. Ethan, would that give us area, counting the grid squares on the inside of the shape? Yes, D works. D and B were very, very similar. E says the area can be found by adding 4 times 3 and 6 times 2. I just asked Jalen, how would we find the area? Did she take 4 times 3 somewhere? Yeah, right here. Well, 4 times 3 is 12. 6 times 2 is what she said we'd have to do right there. And then I didn't write it, but she said, and then we would add them together. 12 plus 12 is 24. Is that what E is telling me to do? Yes. So E also works. So if they are on grid paper, there's lots of different ways to find the area. Questions on that one? No? Okay, this one, a lot of you chopped it, but you didn't find the area. Okay, so we are going to find the area of both of these. If I find the area to the same shape twice, what should happen?
You should get the same answer.
I should get the same answer. If I work the same problem twice, I should get the same answer. What is one way I can cut this up? Carter, what's one way I can cut that up? I don't have a formula for the area of a stair shape. What do I know the formula for? What shapes do we know? What's the easiest shape to find the area of? A rectangle. Carter, could I draw some lines to make multiple rectangles here?
Yes.
Okay, where could I draw lines to make rectangles?
At the top part?
Right here?
Yeah.
Okay, so one of yours, it doesn't have to be this one, it could be that one over there. You should have had a line drawn right there. Where else would I need to draw a line on this one, Carter?
Right next to on the left.
On the left. Yep, right here. Let's go straight across. That would be the easiest. Does everybody now see 3 rectangles? If you have 3 rectangles, you should have 3 formulas. What should all 3 of my formulas be? Sophia, what's my formula for area of a rectangle? You are correct with that, but what's my formula to find area? A equals length times width. Since I have 3 of them, a lot of you didn't have this. A equals L times W. I'm going to do the big one there. A equals L times W. I'm going to do the medium one here. My last one, A equals L times W. I'm going to do the little teeny tiny one there. So when I'm breaking these apart, I like to squiggle out the side lengths just so I can see, do I have all of that I need or do I have to do some math to find the side lengths? On the large one, do I have that distance or that distance given to me? Stella, which of those numbers is important?
The bottom.
The 10, yeah, the bottom. So in place of this length, I'm going to put 10. Addie, am I given the width of that triangle or that rectangle? The big one on the bottom?
Yeah.
What is it? There's the length, so what's my width? 3. Okay, so 10 times 3 is 30. So the area of the large triangle is 30. Now the medium triangle. I'm going to start with this 2. Why do you think I'm going to pull that 2 first? Nolan? It's the whole width, and I don't have to do any thinking. I can just see, hey, I need this piece right there. The value of it is 2. Now, my length is going to make me think a little bit. I'm going to change colors. It's not showing me that distance there, and it's not showing me that distance there. But I do have enough information. I see that from here to here is how much? 3. So I need this piece right here. Ethan, how long is that piece? How do you know? Yeah, it shows if this up here is 2, that right there has to be 2. So what's the whole length, Ethan?
2 times 5.
Nope, 2 plus.
5.
Oh, okay. So you were answering the next question. So it's 5. So now 5 times 2 is 10. So the area of the medium one is 10. Max, what are the dimensions of that tiny rectangle at the top? 2 by 1. So I'm going to do 2 times 1 is 2. To find the total area, we need to add them all up. Again, this is something that a lot of you didn't have, so fix it if you missed it. 30 plus 10 plus 2. 42. What is my label for area? Sadie? Units squared. Why is it units squared? It doesn't tell me what it is. Trick question. Nolan?
Because it doesn't tell you what it is.
If it doesn't tell us what it is, we put in units. Okay? That was one way to find area. What is another way I could have cut that, Reese?
Vertically.
Yeah, I could have cut it vertically. And these are the only 2 ways I'm going to work. Really, you could have cut it into more rectangles, but less is more. Less is better. The less pieces you have to do math for, the better off your life is. So I'm just going to cut it in the fewest number of pieces, which is 3. And on this one, I'm just going to go straight down from each one. I have 3 rectangles, so I should have 3 formulas. Nate, which one do you want to start with? 1, 2, or 3? Left, middle, or right?
2.
The one in the middle? Starting with the hard one?
No, the 3 and 5.
Okay, the far left one, because it already gives me what I need. He said that he wants to use the one that has 3 and 5, or those the whole distances that I need. Yep. So let's write 3 times 5, that's 15. Second one I'm going to have to think a little bit about. Which side length is given? Jack? Okay, yeah, this top little piece, which is 3, and you want to call it the width, that's fine. So times 3. So I need this distance. I know this little piece right here is what? 2. So I need from here to here.
That's 3.
How do you know? Because you know rectangles, and you know if this side's 3, that side also has to be 3. So what is the whole length? 5. Good job. 5 times 3 is 15. Is it okay that like over here I got 30 as my first rectangle, and over here I got 15? I'm working the same problem, I should get the same answer. Am I working the same problem here and here? No. The whole problem is the same, but I broke it into different chunks. So I'm technically working 2 different problems right now with one answer. Last one, dimensions. Sophie? This far right rectangle, what are the length and the width? 2 and 6. 2 times 6 is 12. Now let's add those. What's 15 plus 15? Plus 12? Oops, I don't know. 42 square units. Did we get the same answer? Yes. Okay, 2 different ways to get the exact same answer. Does that problem make sense? Jack, do you have a question?
I did the middle thing a different way.
What'd you say?
I did the middle.
Okay, so did you say, okay, all of this is 6 and I need to take that piece away? Okay, so Jack, instead of combining what he does need, he took out, so when he was trying to find this distance right here, we looked at it as I can add those 2 pieces together. Jack looked at it as I know all of this is 6 and I don't need that piece. So he took 6 minus 1. Does that work? Yeah, that would still get us 5. That works. Okay, let's go down to number 6. I told you we would do it together today. I don't have as much space as you, so I'm going to open up my whiteboard to write mine. Okay, number 6. Let me read it real quick. It says, which shape has a larger area? A rectangle that has side lengths, a rectangle that is 7 inches by 3/4 of an inch, or a square with a side length of 2.5 inches. In your workspace under that problem, okay, here's your words at the top of the page. I want you to just draw a line. It doesn't have to be all the way down the page. We're just separating this into 2 problems. We are comparing the area of 2 different shapes, and all it gives us is the side lengths. So what do I need to do first? I have to compare the areas. Do I have the areas?
No.
So Nolan, what do I have to do first?
Figure out the area.
Figure out the areas. So we have a rectangle, so let's write rect. What do we know about our rectangle, Chase? The length is 7 and the width is 3/4 of an inch. Chase, how do we find the area of a rectangle?
You multiply the
What's our formula? A equals
length times width.
length times width. Okay, and Chase just told us that the length is 7, the width is 3/4. How do I multiply fractions? Reese?
Multiply them straight across.
Straight across, but before I can multiply them straight across, I have to have 2 fractions. Naomi, what's my next step going to look like? Good job. 7 over 1 times 3/4. Now, how do I multiply fractions? Haley?
Multiply straight across.
Straight across. Haley, what's 7 times 3? 4 times 1? Now, we don't have to finish this yet. That might be good enough because is this asking me for the area of the rectangle? No, so I don't have to give my best final answer. It's just asking which area is larger, right? Which one has the larger area? So if the other one is an improper fraction with a denominator of 4, they're already comparable, okay? You could go ahead and flip that into a mixed number if you wanted to, but it's not necessary yet. Now for the square, what do we know about the square? Jack?
That all of its sides are 2.5.
Okay, its side lengths are 2.5. Jude, how do I find the area of a square? Okay, we can still use length times width. That's fine. Or we could use side length squared. Each one is 2.5. So we would have to do 2.5 times 2.5. Is 2.5 times 2.5 4 and 1/4? What did I do to get 4 and 1/4?
You added the 2 whole numbers and multiplied 1/2 times 1.
Yeah, I multiplied the whole numbers, I multiplied the numerators, I multiplied the denominators. That does not work. Okay, but that is a common error. That's why I was checking you. How do we multiply mixed numbers? Chase?
Oh, you have to multiply like the 2 times 2, like on the 2.5, and then plus the 1.
Okay, so he's saying I have to take 2 times 2 plus 1. What is he doing? What's the terminology there? Naomi?
Turning into a fraction.
Almost. What kind of fraction?
Number.
It is a mixed number. He's converting it to a improper fraction. Okay, he is correct. So he said 2 times 2 plus 1. So is my new number 5?
No, it's 5 over 1. 5 over 2. 5 over 4. Wait, 5 over 2. It's 5 over 1 actually.
Why is it 5 over 2, Chase?
Because 2 was the denominator.
The denominator stays the same. I'm going to go out to the side just to refresh your guys' memory how we showed it last year. Remember, we did the wheel around to the top, and then we showed that that just scooted on over. So we have 5 halves times 5 halves. Multiply straight across. What's 5 times 5? 2 times 2. Can I easily compare 21 fourths and 25 fourths? Yeah, so I didn't need to change these to mixed numbers. Who can give me a good final answer? Jack? Tell which one has the larger area and why.
The square has a larger area because the area of the square is bigger. Because the area of the square is 25 over 4.
So let's just say because 25 fourths
Is greater than 21 fourths.
okay, because my work is part of my explanation. I said that my rectangle is 21 fourths, my square is 25 fourths. So then my explanation, I can just say the square has the larger area because 25 fourths is greater than 21 fourths. Raise your hand if I just made that assignment look a lot easier than it did last night. Okay. And part of this is this book. It's just we have to get used to the way they ask questions in this new series and just how to explain problems. Anytime it says explain, you should have a sentence, okay? So what you're going to do for homework tonight is I actually have a worksheet for you. It's very similar to last night's homework. I'm giving you a second chance on it, okay? I am taking a grade on tonight's homework, so don't just slop something down to get it done. Okay, I'm going to go ahead and pass it out, and you guys have the rest of the time to work. You also have your weekly worksheet due Friday.